Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello and welcome everyone into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology. And everyone, welcome into the program. I hope that you're doing well. You have had, we can at least say an exciting week. I hope that it's been good, but we can also say exciting. We hope that you've had a great week and you are ready for some Computer America, because joining us today, as every Friday, will be Ralph Bond. He joins us to talk about a ton of different stories. These can be everything from science, tech, robotics, medicine, you name it. Ralph's going to explain further what that is. But ladies and gentlemen, we have a lot to cover. And we're going to cover a little bit of the current news before we get started with the show. But then we're going to jump right into 4 amazing stories that, if by the time that you hear this, you can go on out to computeramerica.com, find the show notes, and we'll include all the stories, all the links, everything that you need to know, so that if you are simply listening to us, if you can't watch us for some reason, then you can come out to computeramerica.com and find all the links, find all the relevant articles. So with that being said, let's go ahead and just bring Ralph on. We'll get started and just have a fun time with it. So once again, he is our science and tech trends correspondent, and of course, longtime Computer America contributor. Started out for a long time as the Intel Digital Minute guy, and well, that's going to come in relevant for our kind of like interlude to today's show. So, Ralph, welcome back onto the program. How you been?
It's great. It's great to be back. And boy, I'll tell you what, folks, what a news week it's been. But before we jump into that, if you are new to the show, welcome. It's so great to have you. And let me explain. Ben and I, each Friday, what we do is we highlight 4 articles that show us key trends and developments in a host of things: artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, construction tech, space research, physics, you name it. And most important of all, and this is the key, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And as I said before, though, before we jump into story number 1, which I promise is not as R-rated as it sounds by talking about RoboBalls, no, we're going to be talking real quick about Intel, because Intel is kind of near and dear to our hearts. They've, in the past, they've been sponsors of Computer America, and just as really one of the few, really only, I think there's like one in Norway or something like that. But anyways, one of the only not in Southeast Asia chip foundries. So much of our technological world is built on NVIDIA, AMD, ARM, so on and so forth. And they're all built in like one place. It's all Taiwan, Singapore, it's all in South Korea. Ralph, that type of business has really been centered geographically in one place, and a lot of those jobs have left America, except for one really big notable name, and that is Intel, that has kept all of its foundries in America. It's like one of the only ways that America can produce the chips that they need to make these amazing advances in science and technology that we all kind of benefit from. So to talk about Intel is to talk about really one of the last beating hearts of technology in America kind of left. So I love to take time to talk about Intel. And just yesterday, if anyone out there is living under a rock, NVIDIA, you may have heard of them. They they're worth like 18 apples at this point. If Jimmy has 1 apple, but you have 4 NVIDIAs, how many apples do you have? They're worth a lot. They invested $5 billion into Intel and really gave Intel a shot in the arm, saying, hey, we still need foundries. We still need Intel. And you wanted to take a little bit to talk about this because, it's right in your backyard. And so let's chat about Intel for a little bit.
Yeah, yeah. Well, this is very near and dear to my heart because I worked for Intel for 14 years before I finished my career with Autodesk. But with that said, I live in Hillsboro, Oregon, and longtime listeners of the show know all about that, aka the Silicon Forest, as we nickname this part of the country. And right here in Hillsboro alone, there's, even after the layoffs, there's about 17,000 Intel employees. So this big news is near and dear to my heart and very important to my neighbors, to say the least. And what I think is most interesting about this is the plan to co-develop custom chips for data centers and personal computers that fuse NVIDIA's artificial intelligence capability with and GPU expertise with Intel's CPU and manufacturing capabilities. It's this coming together. It's these two monster giants now holding hands instead of trying to compete. What was Intel's greatest challenge over the last, I don't know, you could even say pushing a decade, was not being a very super serious contender in the AI space in terms of GPUs and the kind of architecture you need to support large language models and all this good stuff, right, Ben? You know, I've talked about this so many times.
Intel, they were very dominant 10, 15 years ago. And then I would say kind of the blockchain, cryptocurrency, Bitcoin mining, that whole wave kind of swept the tech space.
Yeah.
And that's where NVIDIA got their first, real big bump, was like, hey, for every NVIDIA card that you can buy, you can make even more money, by using it to mine Bitcoin. And Intel was like, hey, we make processors for PCs, we make them for laptops, that's what we do. That we're not really in the GPU market. And of course now they have ARC and stuff like that. But anyways, Ralph, Intel's kind of sat on the sidelines for a couple of really big tech, kind of waves. And it's really hurt them in the past.
Yeah, and I think overall, to wrap it up here before we go into our first story, I think, Ben, in my opinion, this is great news, not only for Intel, but for our nation's competitive future in artificial intelligence. I think this is a strategic coming together. That's my opinion. Maybe other people don't see it that way, but I sure do.
No, and honestly, like even going back as far as I can remember, like either you bought AMD and AMD had processors, AMD had graphics cards, right? We recommended this on the show many times. Either you buy AMD for CPU and GPU, or you buy Intel CPU and NVIDIA GPU, because they work so closely together. They are so compatible that's the only thing that kind of made sense in the past. So for them to deepen those ties that have been there for decades makes perfect sense. And Ralph, like, we're not going to get into the weeds of everything. I will say, though, that like I've been keeping an eye on Intel, like what their road plan is. Pat Gelsinger, I think, had the right ideas. But unfortunately, for a business that had to be competitive while being transformative at the same time, I do feel like he got the short end of the stick, but I also understand why, the board kind of got antsy about his plans. So
yeah. Well, I'll jump in and say one thing about this, and then we'll move on. But sure. Pat Gelsinger, when he came back to Intel, the big transformative idea that he brought to the table was, and I'll paraphrase it, it's not his words, but my reaction: get over your ego. Why don't we offer our foundry services to other people to make money? Mm-hmm. And we will still do our thing, but why not do the thing for other people? And that was a radical, wild idea in the culture of Intel historically. And ironically, that's what's happening here, in my opinion, with this NVIDIA Intel coming together with NVIDIA and pumping in $5 billion. So with that said, that's my opinion.
Right. The spirit of it continues on. And hey, Intel luckily continues on. So there you go. Looking forward to what comes out of that. And Ralph, I mean, hey, if everything that we've been seeing AI revolutionize, you're going to need those strategic partnerships between like Intel and NVIDIA to bring us the next generation of hardware to run these kinds of software. So looking forward to it.
Yeah.
So, with all of that being said, a little interlude, we'll put a marker on this or something. Let's get into story number one, Ralph, where we are going to talk a little bit about, well, and I think I've seen other projects like this, but this one actually, hey, has a finished thing that we can see and we can show you a video of. So, Ralph, why don't we go ahead and do the story, and in the background, I'll be playing videos and looking through articles.
Great. Yeah, this is fun. This is a fun story. This comes from the Purdue Exponent, which interestingly enough is a student-run newspaper serving the Purdue community in West Lafayette, Indiana. So that's kind of fun right off the top. In the show notes, folks, and Ben mentioned this, if you're listening to us as a podcast, you want to dive deeper into any of these stories, come to computeramerica.com, get the show notes, because we have a bunch, in this case, a bunch of links, a bunch of video links and so forth, and you can check out the story in full. But let's get into this. Researchers at Texas A&M University are working on a swarm of what they call RoboBalls to send to other planets. And you really have to see the images and see the videos to immediately get what's going on here. For example, on the show notes, there's a photo of two of the students working on this, standing by a approximately 6 foot tall ball, but we'll explain this. The spherical robots, or RoboBalls, would be deployed to map alien landscapes by rolling around challenging terrain. And Ben is showing right now on the screen one of their videos showing it rolling around on a empty lot area. It's kind of cool. It looks
like it's having the time of its life. It's going for a swim. It's rolling around fields.
Yes,
it is just enjoying itself.
Again, you have to see it to get it. And the concept, though, what's interesting here is the concept was first conceived by Dr. Robert Ambrose while he was working at NASA way back in 2003. But after joining Texas A&M University in 2021, Dr. Ambrose reignited the idea, and now a small team is working to make RoboBall fit for outer space use. And the two characters that are shown in the show notes photo, graduate students Rishi Jangal, I hope I'm saying that right, and Derek Pravicek, both from Texas A&M's Mechanical Engineering Department, are the primary researchers today who are driving this project forward. And there's two versions of the RoboBalls. The smaller RoboBall 2 prototype with a diameter of about 2 feet, and RoboBall 3, which is 6 feet across and built with plans to carry payloads such as sensors, cameras, or sampling tools for real world, or in this case, outer space, extraplanet applications. We'll see.
Yeah, it's and you know, the videos, like you said, speak for themselves. The pictures are really cool, but you could see how something so simple could really tackle almost any terrain. Like, you know, I can't imagine this thing even being damaged, you know, dropped off a cliff, rolling down a hill, you know, hitting a sharp object. This thing looks great. Yeah,
it's a pliable inflated thing. Again, you need to see the videos to get it. But let's give some details on the mechanics. And this is input I inserted into the show notes that's not covered in the article. So I do that a lot with the show notes, folks. I'll put in tutorials or add a little more additional information. So with that said, here's the bit about the mechanics. RoboBall 2 uses, for example, and this is true for RoboBall 3 as well, uses a 2 degree of freedom pendulum system inside the sphere to generate forward motion and steering. And this internal pendulum shifts weight to roll the ball in the desired direction. So it's remotely controlled. And here's the part that I was alluding to a moment ago. Soft inflated shell or ball outer casing is used for both balls. For example, RoboBall 2 is encased in a 2-foot diameter soft shell that can be inflated or deflated using an onboard compressor and pneumatic tank. This lets it adjust stiffness depending on the terrain. And again, that applies to RoboBall 3, the larger version they're in. And that's what makes it possible to go over some really weird terrain situations. Maybe imagine on the surface of Mars or the moon, for example. And back to the article. Yeah, go ahead.
Yeah, I'm just thinking like a traditional rover, which is more, I think everyone knows what a rover looks like.
Sure.
Looks like a Wall-E from Disney. But yeah, it's more, much more rigid, and there are instances where it got stuck in terrain and whatnot. And some of the terrain that they're just showing in the video would probably get that stuck, but not this. This just kind of rolls in 360 degrees. It can go anywhere.
Exactly right. And so going back to the article, long-term goals include autonomous navigation and remote deployment. And the Texas A&M University team hopes to see RoboBall dispatched from a lunar lander to chart steep crater walls on the moon. And here's the other part. Outside of space, or launched from an unmanned drone to survey post-disaster landscapes on Earth. Wow, okay. And each ball could map terrain, transmit data back to operators, and even deploy instruments in hard-to-reach spots. That's another possibility. And other possibilities, in fact, Rashid Jangal, one of the researchers, said, quote, imagine a swarm of these balls deployed after a hurricane, for example. They could map flooded areas, find survivors, and bring back essential data, all without risking human lives. That's the goal of robots, drones, as we've seen so many times before, but now here's a new potential player that has really unique physical capabilities and the ability to deal with some really bizarre terrain situations. And to wrap things up, upcoming tests will continue to take RoboBall into outdoor environments, with the Texas A&M University Robotics and Automation Design Lab researchers planning to field tests on Texas beaches to demonstrate a water-to-land transition capability and test the robot's buoyancy and terrain adaptability in a real-world setting. Fun story, really a long history of this story going back to 2003. Check it out. It's really great.
I do wonder if they are taking any kind of inspiration. Ralph, I'm not sure if you remember the STEM toy Sphero.
Yes, I do.
I can pull up an image for people who are watching.
Yes.
Yeah, it's these smartphone controlled ball thing, and I think and I remember talking with the gentleman out at CES. I think they, kind of drive this toy, the exact same way with, kind of the free floating axis and whatnot. They, of course, have made it much more rugged, durable, and, possible to do this. But yeah, very interesting idea that I've seen before. I hope that they do things with it that, like you said, payload and sensors and whatnot that make it really, really useful. So,
yeah.
And hey, the best part about this, again, is the video and the pictures of this thing. It's, really incredible. So, with that being said, story number one, great. Texas A&U, A&MU. There we go. My wife from Texas would kill me. But anyways, story number two, we're going to talk about paint and buildings, and we're going to, right here, live on Computer America, watch paint dry. It's going to be exciting things. So, Ralph, I'll pull up the video. You get started talking.
Yeah, actually, we're going to watch paint sweat.
Oh, we're going to watch paint not dry, wet.
We'll explain here. This one comes from Anthropocene magazine. Headline, this paint sweats to cool off buildings. No energy required. Once again, I'm very prone to be interested in construction technology related things because the last 10 years of my career I spent as the architecture, engineering, and construction press relations manager for Autodesk. And so in that 10-year period of time, I learned so much about construction technology. And so it's a near and dear topic for me. But this is a fun story. So let's get into this. It's a little bit of setup here. Ultra bright white paints are the go-to when it comes to cooling buildings. I think we all know that. For example, you see a lot of high rises with the rooftops painted in white. Those paints work by reflecting as much of the sun as they can, of course. But now here's the news. An international team of researchers, and this is a team with people from China, Singapore, Saudi Arabia, the UK, and the United States. What a team. Have now made a new cement-based cooling paint that outperforms those traditional white cooling paints that have been used for many years on buildings. The new paint reflects sun rays and emits heat as infrared radiation, which passes through the atmosphere straight into space in a phenomenon called passive radiative cooling. Now, but what makes the new paint unique is that it also releases water to achieve cooling via evaporation, much like human skin does. How about that?
And really, there's a video that I'm going to pull up here in just a second. But to see it kind of absorb water like that, you think, oh, okay, this paint's not doing its job. But no, it's kind of doing a little bit the opposite of what we expect paint to do,
Yeah.
and then doing something we never expected paint to do.
I know, and that's why I think it's so clever and interesting. And by the way, just a quick note, back in August, we covered a news item about sweating data centers. Remember that? Using water evaporation, for cooling. So this is another example of water evaporation for cooling purposes. Kind of fun. But this combination of multiple cooling mechanisms gives the new paint, super cooling powers. In a pilot test in Singapore, one of the most humid cities in the world, the paint achieved up to 10 times higher cooling power than commercial existing cooling paints. This amounted to electricity for air conditioning, savings of 30 to 40% compared with traditional radiative cooling paints, the white paints that we started the story with. Now, traditional radiative cooling done via paints, textiles, and other materials has become a popular passive cooling technology for many, many years, but it does not work well in humid places like Singapore. That's because water vapor in the air traps heat near the surface and prevents it from escaping into the atmosphere. But to counter this, the researchers created a cement paste-like paint composed of a porous calcium silicate hydrate network. The paint replenishes its water supply by absorbing rain and water vapor in its environment, and its interconnected porous structure holds water and slowly releases it, much like sweat or sweating. How about that?
I do wonder about so much of this, and I'm sure that anyone who's interested can go to the research article and really dig in.
Right.
But yeah, just alone, I'm kind of thinking, what about the weight? It's which I'm sure we'll get to later in the notes. But yeah, there's so much going on here.
That's a good point. In fact, that's an interesting point. How thick is this paint? How much weight does it add to the structure? How much implications does that have on the infrastructure to put a building together? Well, good points, but I still think it's pretty damn cool.
It is.
So the new paint, to wrap it up here, the new paint that they've developed, this cement-based paint that sweats, reflects 88 to 92% of sunlight. What? Emits 95% of heat as infrared and holds about 30% of its weight in water. This is really, if you're interested in construction and green technology for the construction industry, I think this is fascinating in terms of savings on air conditioning. Wow.
I hope something like this will be an option where, one day you kind of just go to the hardware store and be like, here's cooling paint for the side of your house. Here's, here's reflective paint for your roof. Here's this, that, or the other.
Yes.
Yeah. Just having the option, Ralph, I think would be super, super cool. And, it's something that is so minimally, it's not like you have to install an array of solar panels. No, it's just, hey, paint the building, which you're probably going to do anyways. Just paint it with this stuff instead. And that's going to be a real breakthrough in, I think, helping with heat and, global warming and all these issues. So
yeah, good point, Ben. In fact, you and I have said this to each other many, many times. It's not so much that this would replace solar panels, but would hold hands with that technology and a combination of things to create an incredibly efficient building. So that's fun. That's cool stuff.
Correct. Just a little bit of everything, and hey, making buildings sweat. I'm sure there's even, Ralph, ideas of what to do with the water as it comes out of the building, and maybe use that to water the landscape or something like that.
Interesting.
I don't know.
Some kind of capture system, maybe. Yeah.
Who knows? But hey, very, very cool story for number 2. Number 3, we're going to talk about, human poop. There you go. We talk about RoboBalls, now human poop. This is going to be a very highbrow, classy show that we got going on here. Ralph, let's talk about, honestly, what has become a major theme and, a trend, a tech trend, which is once again turning waste. And I can't think of anything that is more the epitome of waste than human waste, waste into something useful. So,
Well,
story
that's
number 3.
just right. We flush billions and billions of gallons and tons of potential gold down the toilet in this world. And this is a story
is that what you're doing? Because what I flush is not gold. I promise you.
well, it has relative to its potential,
Okay.
the content's potential. And that's what the story is going to be all about. This comes from The Guardian, which of course is a UK publication. Here's the headline: Biochar. We'll explain what that is. Biochar from human waste offers a circular solution to fertilizer shortages. And the subhead is: Excrement contains nutrients needed for crop growth, and a new source of them could cut farming's huge CO2 output. So there's a lot of things going on just in that headline and subhead, but let's get into it. We've got the research paper, linked to the original article, of course, from The Guardian. All of that's in the show notes. So here we go. Charcoal, or in specific biochar, made from human waste, could help solve fertilizer shortages as well as reduce pollution and energy use, a study from Cornell University has found. So this is coming out of Cornell University. Biochar is a form of charcoal made from organic matter treated at high heat, which often is used on farming soil as a fertilizer. But the Cornell University study estimated that biochar, made from human solid excrement, could provide up to 7% of the phosphorus needed around the world each year. And although biochar process converts only solids, nutrients taken from urine, I know this is gross, nutrients taken from urine could be added to it. And the researchers found this combination could provide 15% of annual phosphorus application, 17% of nitrogen, and up to 25% of potassium in the world of agricultural fertilizers. Wow, pretty amazing.
It's once again just, you need these things in the soil to grow your crops that then people eat, but then, people of course eat it, poop it out, what have you. Ralph, you are taking it out of one environment and just throwing it away at the end of the cycle and turning it into that circular, kind of economy that we've talked about. I think just even the past couple of shows, talking about recycling batteries and the end of life for electronics and doing, the end of life for solar panels, for instance, like that comes up time and time again. How do you keep it kind of going instead of just a landfill or completely broken down or thrown away or disposed of? How do you keep it going? And this is it.
Exactly. Yeah, this is a great example of that circular scenario that you're alluding to. And but let's be clear, the use of human waste for fertilizing farmland is not new. It's not that this is a new idea. It's a new way of doing it, okay? Mm-hmm. Because treated sewage sludge is already spread on farmlands around the world, but its use is controversial as it often contains microplastics, heavy metals, PFAS, which is forever chemicals. Usually you hear the term forever chemicals, pathogens, and pharmaceuticals even, right? Trace elements. And these researchers at Cornell say biochar can avoid this problem by separating the waste at the source. And the study estimated that biochar process could decrease the weight and volume of solid excrement by up to 90%, which represents a significant gain in efficiency when compared with transporting sewage sludge for use as fertilizer for farm fields, due to the latter's high water content. In other words, sewage sludge, as it is used today, treated sewer sludge, weighs a lot because of its high water content. If you use this incredible heat process to turn the human excrement into biochar, it's going to reduce the volume and weight by 90%. That's why they're so excited about this. And the biochar production process also allows nutrient proportions. This is cool. Also allows nutrient proportions to be adjusted according to the needs of individual crops. So you can say, well, for soybeans, we need this amount. For corn, we need this, and so on and so forth. That I think is pretty cool.
Yeah. It's really incredible that, first of all, I did not know that we already used human sludge to, sewage to treat fields. That's kind of news to me, but then again, I'm not a farmer, so who knew? Like, I knew we used like cow manure and, chicken manure and stuff like that, but I didn't know like human manure essentially was what we were using. But no, this seems to be taking a pretty unrefined product and turning it into a refined product that better solves the problem that it's already trying to solve. So
exactly, and going back to the story, this can address problems associated with fertilizer use, such as weed growth, and when excess nutrients leach into groundwater, causing rapid growth of algae, which depletes oxygen availability and reduces the sunlight available for underwater ecosystems. What that last paragraph refers to is the traditional or current use of treated human waste sludge to fertilize fields. This overcomes that problem, because that stuff, with its heavy amount of water content and so forth, encourages groundwater leaching and growth of algae and other things like this. This new idea of biochar that they've come up with gets away from that and avoids that problem. So it's a win-win-win all the way around, and it creates that circular economy we've talked about.
Yep. No, it definitely seems like something that Ralph, honestly, we can look at places like Japan that live on an island. They don't have like a lot of farmland. Ralph, they honestly do recycle like 90% of all of their metals, woods, food waste, stuff like that. I think the entire world needs to kind of get to that point where we can't just say, if it's waste, we dump it somewhere, because we're kind of running out of places to dump it that don't affect people. So instead of dumping it, we need to recycle pretty much everything. I don't mean that as like a, like an environmentalist. I mean that as like, well, if we're going to keep living here and enjoying our planet, we kind of need to recycle everything. It just makes sense.
Oh, yeah.
So there you go. So story number 3, great. Didn't think we were talking about poop today, but hey, that's on me. So story number 3, story number 4, and I will say, before we jump into story number 4, Ralph, I don't know if you have this problem. I know that I did. We're two-story building, and the Wi-Fi router, because people don't like the look of routers for some reason. It's shoved in the back of a pantry with a bunch of other cables, with another concrete wall separating it.
Yep.
Ralph, there's almost no Wi-Fi signal. So for everyone out there who's having this problem, our solution before this was honestly a really bad one, where we have these little pods that you plug into outlets and they kind of repeat the signal.
Yep.
They capture what weak signal you have and then repeat out a stronger signal. But of course, even that is not a good idea. Ralph, this week I went out and bought a $100 router off the shelf at Best Buy.
Okay.
And I do have a direct connection, like a cord that comes from the first one. And we have like a big switch, a cord that comes down to the first floor. Instead of it just going straight to my computer and I was the only one benefiting from that connection, I took a $100 router. And if the $100 one was, and by the way, Ralph, if you don't know this, go to Best Buy, there are $800 routers sitting there.
Oh, yeah.
There's $800, $100, and everything in between.
Sure.
So anyways, I bought the cheapest one, plugged it in, and you can go to the settings and set it up not as your primary router, but as a secondary router.
Yes.
And what it will do is you just plug it into the first router through this cable that I had, and it will repeat the Wi-Fi signal, and it will proliferate just as good as a primary router. So, ladies and gentlemen, if you're having trouble getting Wi-Fi signal to other parts of your home, consider running a singular Ethernet cable through a wall or something like that, and then getting a second router. Highly recommended.
It's uncanny, Ben. A number of years ago, I did exactly that. I have where I'm sitting in my home office upstairs on the second floor on the far western edge of the house. I have the main router. And then I did exactly what I routed a cable down to the garage for the first floor and have another router that's doing exactly what you're talking about. So again, however, in another property, a rental property we own, we have used the ERO mesh network repeaters, and those have worked very well for us. But you're absolutely right. I love my solution.
It's the exact same thing. You're essentially setting up a mesh network of your own because, it's not like you have two different networks running. It's the exact same network through and through. Same thing. Eero is a great product as well. It's just, you can kind of do the same thing with cables, but of course Eero uses no cables, just, the one that goes into the, the hub or the main one. Anyways, so I bring all that up because I'm saying Wi-Fi signal, incredibly fun to have for phones and games and TVs and streaming and whatnot. But hey, there are other uses for good Wi-Fi. And also it's just a little PSA saying, hey, if you want better Wi-Fi signal on the other side of your house, get a second router. But anyways,
that's a
story
great
number
idea.
4. Story number 4 kind of picks up on the idea of a strong Wi-Fi signal and what it can do, which, by the way, Ralph, like this article kind of comes out, and I'm sure this is about the time that Apple announced their Apple Watch, where they were saying they can measure hypertension just with a wearable. So not like you're going to throw out all wearables, but hey, for so many other applications, this could be another additional point of data and be very cool. So story number 4.
Right. And to set the story up here, and by the way, this comes from the University of California, Santa Cruz. The last story of the 4 we do each week is usually something related to medical technology, and this fits that bill. But before I even get into the headline for the story, the key trend, remember what we talk about here are trends, early research, trends, things to watch. Friends, what I'm seeing, and I know you are too, Ben, is more and more looking at Wi-Fi beyond its original intent. What can you do with Wi-Fi beyond just give your smartphone access or your laptop or your computer, whatever? What else can we do with this? And technologists around the world are realizing this is a fabulous technology that can be tapped and repurposed for other things as well. So with that said, the headline here, again, from the University of California, Santa Cruz news website, Wi-Fi signals can measure heart rate. Subhead, no wearables needed. So let's get into this. This is really interesting. Research papers in the show notes. Check it out. Let's start. Traditionally, measuring heart rate requires some sort of wearable device, whether that be a smartwatch or a hospital-grade machinery, the thing they put around your arm and pump it up and all that good stuff, right? But new research from engineers at the University of California, Santa Cruz, shows how the signal from a household Wi-Fi device can be used for this crucial health monitoring with state-of-the-art accuracy without the need for a wearable device. And how they pull this off, you'll find out in a minute here, is absolutely fascinating. And by the way, a little side note, though, on our August 15 show, we talked about how new AI-powered Wi-Fi technology can identify and track individuals without using cameras. And again, this goes to my point, key trend to watch, increased use of Wi-Fi beyond the original intent. That's a trend, friends. Tuck it away in your mind and just keep watching for this. It's going to be more and more and more, I predict.
Yeah, I can immediately think of an application where, Ralph, we're not there yet, but we're heading towards a future where you walk into a store, you pick up items off the shelf, and you just walk out the door because they are, they're the cameras or AI or even this technology that you were just talking about with Wi-Fi would be able to identify this person picked up this item, charge it to this account, and the future of a no more cashier store is not very far away. I promise.
No, and in fact, you and I think covered a story about some very innovative shopping outlets with that kind of technology in place, but very early, very nascent stuff. So going back to the story, the University of California, Santa Cruz proof of concept work demonstrates that one day anyone could take advantage of this non-intrusive Wi-Fi based health monitoring technology in their homes. The team proved their technique works with low-cost Wi-Fi devices, demonstrating its usefulness for low resource settings. Now, here's how it works. The UC Santa Cruz team designed a system which they call Pulse, Pulse-Fi, Pulse-Fi, for accurately measuring heart rate that combines low-cost Wi-Fi devices with a machine learning algorithm. There's your artificial intelligence, right? And here's how the system works. Wi-Fi devices push out radio frequency waves into physical space around them and toward a receiving device, typically a computer or phone, of course. As the waves pass through objects in space, some of the waves are absorbed into these objects, causing mathematically detectable changes in the wave. Keep that in mind.
Yeah, and by the way, we've had Netgear and all Asus and like all these other companies that make these things, and that has been such a focus even for the past 10 years because Ralph, routers nowadays will kind of detect the walls of your house. Not saying they'll detect the people and compensate for it, but they'll detect the walls of your house and actually and that's what these $800 routers are for. They will compensate the signal strength to overcome, barriers or improve Wi-Fi signal, based on the resistance that they detect. So this technology is already there, and they're using it for medical though. That's very novel.
Very clever, yeah. And going back here, PulseFi, this system they've created, uses a Wi-Fi transmitter and receiver, which runs the PulseFi's signal processing and machine learning algorithm. And the team trained the algorithm to distinguish even the faintest variations in signal caused by a human heartbeat by filtering out all other changes to the signal in the environment or caused by activity like movement. This is so articulate and so amazing an achievement. The faintest variations in signal caused by human heartbeat? Wow. The team ran experiments with 118 participants and found that after only 5 seconds of signal processing, they could measure heart rate with clinical level accuracy. What? And to wrap it up, at 5 seconds of monitoring, they saw only half a beat per minute of error, with longer periods of monitoring time increasing accuracy. Fascinating, new twist, new use for Wi-Fi. Love it.
I am both amazed and I immediately think of, what kind of applications. The first one I can think of, Ralph, instantly is, in a hospital setting, even, like they said, in a low resource setting. I would not call hospitals low resource settings, but being able to monitor, the heart rate of even patients sitting in the ER waiting for care, you can kind of keep track of them,
Good one.
Sleeping in rooms. And so they aren't being monitored, things like that. Very, very cool. And then the other one, Ralph, I think of immediately is security. Here, we have like a security system and we have these sensors everywhere that kind of detect motion. And then it'll be like, hey, someone's in your house. You're like, no, wait, no, that's just the cat. Being able to pick up different signals like that, Ralph, how do you break into a property when it can detect your heart beating, just by being there?
That's an interesting twist.
Maybe security systems will have something like this. Who knows? Very, very cool. And this could honestly help so many lives and so many people. So amazing story to end with, and that is story number 4. Ladies and gentlemen, if you've been following along in the show notes, you can of course find story number 4 there with the links and again the research paper. But you may notice we're not done. There's more. So to keep the show kind of condensed, and we ran it a little long today, but that's okay. You may notice that there are other stories, and these stories are just as good, just as important as other stories, but we just don't have time for them. So we're going to give you the headlines. We're going to let you know that, hey, you can come out to computeramerica.com. You can find the show notes. You can follow the links to find out more, but we'll at least tantalize you and show you that, hey, there is more fun stories out there. You just have to, find them like Ralph does. So Ralph, let's at least do the headlines.
Yeah, this is great. This comes from the first one of 4. We'll do 4 honorable mentions. Comes from Canary Media, funny name, but it's actually Clean Energy Journalism for a Cooler Tomorrow is their premise. And the headline is California's first solar-covered canal is now fully online. And I don't know when it was, a year or more ago, we talked about people proposing the idea of covering these canals that feed water to the agricultural communities in California. Why not cover them with solar panels? It'll thwart evaporation and generate energy. And the first solar-covered canal is now fully online in California. Wonderful story. Check it out.
Looks super cool.
It does look cool. Yes, that's another win. It's not ugly.
Mm-hmm.
The next one comes from newscientist.com. 3D printed electronics can dissolve in water for quick recycling. Ben, you and I have over the last couple of years have seen so many innovations. This idea of, can we make circuit boards break down easily in the environment? Can we make them do this? Can we make them do that so that they're not such a challenge for recycling? Now they've got 3D printed electronics that can dissolve in water for quick recycling. Wow.
Have you seen the GIF of the raccoon taking the cotton candy to the water and, kind of trying to wash the food like raccoons do? And it just instantly, let's see if you're watching the video portion.
There you go.
I think about this and people taking their phones to the bathroom and it just
gone.
the phone just disintegrating in the toilet when they drop it in. But yeah, dissolvable electronics. I get it.
That's cool. Hilarious. That's a fun video. And the next one comes from techexplore.com. Another one of these construction related things, or building related rather. Ice cooled buildings could ease strain on power grid. Ice cooled buildings. This is
what is
really
old is new again.
There it is. And it's another one from Texas A&M University, by the way. Salute to them. And then the last honorable mention is from medicalexpress.com. Novel backpack enhances stability for people with ataxia. Wow, this is really cool stuff. Check it out.
That's really incredible. And hey, that's a condition that, Ralph, we do a lot of robotics and electronics. And by the way, the music means that we're wrapping up, but the ones so that people can essentially, feed themselves or brush their teeth or, do basic things like that. But no, this is full blown walking. Very, very cool. And hey, ladies and gentlemen, computeramerica.com. If you want to find the picture, the show note, the article, all of that, you can find at Computer America. At the top, we have a whole section for Ralph Bond. And ladies and gentlemen, I didn't say this at the beginning, but if you want to hear other segments by Ralph, they're all in that section. And stories, shows from a month ago, 2, 3, 6, a year ago are still relevant today because they are so forward looking. So I encourage you to go check that out if you're looking for something to listen to. So with that being said, Ralph, thank you so much for joining us here on Computer America. Ladies and gentlemen, have a great weekend. Do something fun. We'll be back next Friday. Until then, hey, we'll catch you next time. Have a good one. Have a good weekend. Bye, everyone.